All right, guys, welcome back. Thank you again for watching. Robbie here with you. Today, we're going to talk about the basic refrigeration cycle and heat. So let me start sharing the screen because I don't know if you know, I make a lot of PowerPoint presentation. Share. Okay, we're going to talk about heat, latent and sensible heat, energy, heat versus temperature, the evaporator, compressor, expansion device, and the compressor, the four parts of the refrigeration cycle, and the three states of matter. Then finally, we talk about my hat at the end of the class. Alrighty, basic refrigeration. First law of thermodynamic, because we are in the thermodynamic business. Thermodynamic is a fancy word for air conditioning. Energy cannot be created or destroyed, but energy can be converted from one substance to another, one form into another. We have different kind of energy, potential energy, kinetic energy. We deal with thermal energy, which is heat, and we deal with electrical energy in our business. We also deal with mechanical, but we don't mention it too much. Alrighty, so energy. I drink coffee, give me energy. Right, the energy of the battery, give light, etc., etc. Energy cannot be created or destroyed, and heat is a form of energy. That's what we deal with. And in refrigeration, we cannot create energy. We cannot create heat. So refrigeration is the removal of the unwanted heat. That's how we can remove it. We cannot create it. We cannot make cool. Cool doesn't exist. The coldness is the absence of heat. So refrigeration is the removal of heat. Cold is the absence of heat. When we say cold, that means air, heat removed from it. In physics, heat is the transfer of thermal energy, which is driven by the molecules of the vibration of the atom. The faster the molecules go, the hotter the substance gets, water or air, or whatever. The slower the molecule spin around the atom, then therefore the colder it gets, right? The presence of kinetic energy will add the heat, and the removal of the kinetic energy will remove the heat. It is very important to understand this in the thermodynamic business. I will cover it more in details, atomic structure, when I cover the electrical class. It's very important. Okay, let's move on now. Temperature versus heat. Temperature is the measurement of heat. Don't get confused between temperature and heat. They're two different things. All right. Temperature is a form of energy. I'm sorry, heat is a form of energy. Temperature is how we measure the heat. All right. Same thing as square footage is a measurement of a house or of land. Gallon or ounce measurement of liquid. Cubic centimeter mass, pound or kilogram is a measurement of weight. So therefore, temperature is just a measurement of heat. Temperature is a measurement of sensible heat, which we'll cover that later. Now, let's move on. We have Kelvin, Celsius, Fahrenheit, and Kelvin, Rankine, Fahrenheit, and Celsius. Kelvin and Rankine is more scientific. The reason we have those because that reaches, that's for scientific, so we know understand more about absolute zero. Absolute zero when all molecules cease to exist. In theory, we can never get to absolute zero because energy cannot be destroyed, and heat is a form of energy. So people think it's cold. The coldest spot on Earth was negative 89. Negative 410 was the moon, and 454 is deep space. So even in deep space, we still have heat because heat cannot be destroyed. This is important to understand because we need to understand that heat is energy. Alrighty, so this is showing the conversion, the example of temperature we need to know. Easy to remember, 16 is 61, 100, 212, 0, 320. And guess what? When we get to cold temperature, negative 40 is same negative 40. Negative 40 Celsius is the same as negative 40 Fahrenheit. All right, let's move on now to the three states of matter. We have solid, liquid, and vapor, alrighty? The ice in my glass is solid. The liquid in my glass, I mean, the water is vapor, is liquid. And the hot water steaming from my coffee is vapor. We know the stuff from high school. Alrighty. And in nature, water keeps going, vapor, liquid, vapor, liquid. In refrigeration, we deal with vapor and liquid. Thank God we don't have to deal with the solid. We also deal with expansion, compression, condensation, and compression and expansion, which I'll cover that in a little bit. We have latent heat and sensible heat. Latent heat Latent heat is the heat transfer without temperature change in a substance. For example, what's going on in my glass right now, this is latent heat going on right now, right? The ice, the water is not changing, same temperature, 32 degrees, but heat is added to the glass and ice is melting. Ice is melting because heat is added, but temperature remains the same. Therefore, it's called latent heat, when a change of state, but not change of temperature. Right now, ice is melting, changing state. There's good ice cold water. But guess what? Temperature always 32, will continue to be 32 degrees or 0 Celsius until the ice melts. Then we go into sensible heat. Make sense? Sensible heat is heat added causing change of temperature. Latent heat is heat added, no change of temperature. So sensible heat, as heat added or removed, the temperature will change. Sensible latent heat or hidden, as heat added or removed, temperature will not change. 212-degree boiling water will continue to be 212 degree at sea level. Same thing with melting ice. This is important because in the condenser and the evaporator in the system, we have latent heat going on when we deal with superheat and subcooling. Now, the basic refrigeration compression, the vapor compression cycle, it's made up of four main components. The evaporator, its job is to remove the heat. Compressor, job is to circulate the refrigerant in the system and increase the pressure. The condenser, as the job is to remove the heat, and the metering device that regulates the flow of the refrigerant in the system. And we'll cover that in details. We start with the evaporator because that's where the heat is being removed. Well, let's follow the heat. So in the evaporator is located inside the house or inside the refrigerator. His job is to remove the heat. And in the evaporator, the refrigerant comes in cold liquid vapor in and goes out superheated vapor, cool vapor out. And heat comes in, air enters the evaporator with heat in it, air comes out with heat removed from it, or colder air out, or heat removed from the cold air. Next, we have now the refrigerant goes in the compressor. It enters cool vapor in and goes to the compressor and hot vapor out. The compressor has only one job: suck, compress, and discharge. That's all it does. Not very smart. It's not. It's the heart of the system because its job also to circulate the freon, to move the refrigerant around. Next, we have the condenser. Well, the metering device's job is to regulate the flow of the refrigerant, and warm air comes in, and mixed liquid vapor comes out. Because every time you do expansion with every time you spray a bottle, liquid vapor comes out in the sprayer. We have no choice about 80%, 20% mix. The metering device's also job is to regulate the flow of the liquid refrigerant in the evaporator. Same thing on the California highways. We have the metering lights regulates the flow of the cars. The expansion device's job is to regulate the flow of the refrigerant. A similar way. And we have many kind of metering devices: electronic, thermostatic, capillary tube, orifice, and automatic valves. And we'll cover that in details when I talk about expansion valves. And of course, we have the condenser, which is the heat remover, and condenser, that's where the condensation happens there. Hot vapor enters and warm liquid comes out. That's called subcooling. When vapor condenses to liquid, it's subcooled vapor, subcooled liquid, and the condenser's job is to remove the heat. You go outside your house, the condenser feel the hot air, feel the air coming out of the fan. You can feel the hot air coming out. Or go behind your refrigerator at home, you can feel the hot air coming out because we are in the heat removal business. All right, and that's your refrigeration here. The heat enters from the food, enters the evaporator heat. Heat is transferred through the suction line to the compressor, and then the heat goes out in the condenser out to the room because we are in the heat removal business. Now, there's a YouTube video. I will post it in the chat at the bottom. The professor at this college, he also make the water boil without heat by removing the air. We can also, that's what's happening in the evaporator. The compressor comes on, creates a vacuum, and the air releases and cause the refrigerant to boil, because you can also make the Freon make anything boil by removing the air around it. So in this video, you can watch later, the room temperature was 20.6 Celsius, which is room temperature, about 72 degrees Fahrenheit. He put a vacuum pump and the water will start to boil because the air above the water is gone. So now the water is going to go back to its normal state, hydrogen and oxygen. And then as it boils, the molecules slow down and it cools down. So you can boil water at room temperature without heat by removing the air around it, by putting the water in vacuum. This is important because that's what's happening in the evaporator. The other way you also, because evaporation is a cooling effect, you got a water with room temperature water. You got a rag and spin it around, and that rag should cool temperature. Now this rag is cool. Oh, wow, very cool. Cool me down. Why? Because evaporation is a cooling effect. Room temperature water, spin it, make it evaporate, it will cool down. Because evaporation is a cooling effect. Same thing you do with the rubbing alcohol. I forgot to bring it. You put rubbing alcohol on your hand and it evaporates, you cool down. And we have package AC system, and of course must have metering device, compressor, evaporator, and condenser. At home, same thing, but it's split system. One side is the condenser outside and the compressor, inside the expansion device and the evaporator. And heat occupied space enters the evap, and then hotter air comes out from the condenser. More heat's being removed because we have the compressor creating heat, the motors in the system creating heat. More heat's being removed than observed in the system. We'll cover that in details later when we talk about heat pump. So the basic refrigeration system, I like to do the red is the high pressure vapor hot. The orange is the liquid pressure hot, warm. Dark blue is the liquid vapor mix cold, and light blue is 100% cooled vapor. Now we have it's a diamond. The top side is the vapor side, left side is the low side. And then system number one, system is off, Freon in liquid form. Number two, compressor creates low pressure, cause the Freon to boil. Freon begins to boil and reach the boiling point, and that's latent heat, change of state. That's why it changed color to light blue. Freon now 100% vapor out of the evaporator back to the compressor. We better have 100% vapor to the compressor. Next, compressor will suck, compress, and discharge, and compressor on creates its higher. Then compressor will discharge into the condenser. Freon begins to condense and reach its condensing temperature, and that's the latent heat, change of state, not change of temperature. Then at the end of the condenser, 100% liquid out of the condenser enters the metering device. 100% liquid enters the metering device. Metering device will expand at drop temperature, 80%, 20% liquid vapor mix, or 75-25, close enough. And then Freon enters the evaporator, and circles we go. And that's your refrigeration cycle: compressor, condenser, metering device, evaporator, condensation, evaporation, compression, and expansion. And heat enters the evaporator, heat is removed from the condenser. Another way, look at another diagram here. This is also another way looking at it. This is explaining superheat subcooling. Next chapter will cover that. The outdoor unit, indoor unit, and also another way looking at it. We're going to stop here. That's enough for now. Next class is going to be superheat, subcooling, pressure enthalpy, pressure and temperature entropy chart, the fun stuff, the chemistry part of this business. This is very exciting. We will cover that next time. Thank you very much for today. Now, my hat, Death Valley, California, one of the hottest places. It was so hot, my cell phone stopped recording. It says too hot, shut down. So I figured it's fun to comment. I like to always leave the class on a happy note. All right, thank you. Peace. I will see you next time, and make sure you leave a comment. God bless and have a wonderful day.